is going to explain how to find the domain and the range of a continuous graph. So I'm going to analyze the graph in number 7 first, and remember that the domain is associated with the x values. Here's my x-axis, and the range is associated with my y values. Here's my y-axis. When I analyze this graph, the first thing that I notice is that I've got 2 arrows coming from both ends of the graph. So those arrows are telling me to assume that this graph's pattern continues outside of my viewing range. So that means that horizontally, this graph is going to continue to grow infinitely in both directions. So therefore, my domain for this graph is all real numbers. And the interval notation for that, negative infinity to positive infinity, soft bracketing that up. My range, however, is a little bit more interesting in this problem. Notice that I've got the high points here at the top, and I've got low points at the bottom. I'm only concerned with the y-coordinate when I'm trying to determine my range. So here, each plotted high peak has a y-coordinate of 0. So it doesn't really matter what x is when I'm trying to determine my range. The interesting feature about this graph is that each peak point has a y-coordinate of 2, and each minimum point, each point at the bottom on the low end, has a y-coordinate of negative 3. So that means that vertically, this graph is going to fluctuate between positive 2 and negative 3. And I'm going to assume that this pattern continues outside of the grid because that is what the 2 arrows on the end are telling me to assume. To write my interval notation, it must be written in numerical order. Negative 3 is the least value, positive 2 is the greatest value. I hard bracket on both because the graph is solid black at those 2 points. So I'm assuming that these points are on, or these values are on the graph, the points are on the graph. As far as inequality notation goes, the inequality can directly reflect what's happening here with my range values. I'm going to use the variable y in my inequality because y is associated with range, and I'm going to fill in less than or equal to between y and each of the numbers on the end. Okay, let's analyze the graph in number 8 next. So notice that number 8 has only one stopping point right here, and this is going to be the ordered pair negative 1, 0. This is my x, this is my y. Vertically, I've got the arrows going off in either direction, and vertically I'm just assuming that this graph is going to continue to widen as it goes off the grid vertically. Therefore, my range for this graph is all real numbers. The domain for this graph is a little bit more interesting. This graph definitely has a starting point right here, and then it's traveling in the direction of positive infinity. So the least x value for any ordered pair that was used to create this graph, the least x value is going to be negative 1. This curve was created by connecting a series of points that you don't see. So we're always looking at the xy coordinates of all the points that were used to create the graph. Here I've got the stopping point of negative 1, 0. So that means that the least x value for any point plotted is going to be negative 1. All of the other x values used to plot the points to create this curve are going to be greater than that. So my domain is going to be negative 1 going in the direction of positive infinity. I'm going to bracket this up with a hard bracket because the graph is black solid at this turning point. So I assume that that point is on the curve. Therefore, negative 1 must receive the hard bracket to imply that it's part of the curve. As far as an inequality goes, this is just simply going to be x is greater than or equal to negative 1. That's going to be the inequality that goes with that interval notation. Okay, moving on. Let's look at a graph like number 12. Number 12 is bound up on both sides. Number 12 is bound on both sides. So here I'm going to go ahead and identify the ordered pairs. Let's see, horizontally, I've got 1, 2, 3, 4, negative 4. Here I have negative 4, positive 2. horizontally I've got 5, 0. So as far as my domain goes, I'm only concerned with the x-coordinate of the ordered pairs. So this graph's horizontal spread is going to go between -4 and +5. And I'm going to hard bracket, because both endpoints are solid. And then my inequality is going to be -4 less than or equal to x. Remember, x is associated with domain, less than or equal to +5. And then vertically, let's see, vertically I've got the point 1, 2, 3, 4, 5. This is the point 0, 5. Remember, I'm only concerned with the y-coordinate now for range. And then the lowest peak on this graph has an x-coordinate of whatever, but the y-coordinate is -3. I'm only concerned now with top to bottom. So this graph vertically is going to fluctuate between -3 and +5. I'm going to hard bracket, because the boundary points are solid at that point, so assuming that they're on the graph. And then my inequality is going to be -3 is less than or equal to the variable y, because I'm discussing range now, and then my other boundary point is 5. Comparing this to number 11, since it's on the screen, number 11 is exactly like number 12 with the exception of the open circle right here. So that means that this would receive the soft bracket in my interval and the strict inequality, whatever it may be. Here I would have the hard brackets around this and the inequality with the equal sign, the equal to portion with it because of the solid circle. But I will let you figure that one out on your own. It's exactly like number 12. And let's see, let's look at, 14 is exactly, well, let's look at number 14. So number 14 has one stopping point, and then it's going off in the direction of infinity. So let's first identify the ordered pair for the stopping point. I've got -2, -4. And remember, this is my x-coordinate, this is my y-coordinate. Here the graph is going off the grid with that arrow in the direction of positive infinity. So it's going in the direction of positive infinity. And let me arrange this a little bit better. So this is going to be my x-coordinate, this is my y-coordinate. So this graph has a definite stopping point on the grid, but it's traveling off the grid in the direction of positive infinity. So that means that for my domain, I'm only concerned with the x value or the x member of my ordered pair. All of the x values that were used to graph, plot points to create this graph, -2 is going to be the least x value. So this interval notation starts at -2 in the direction of positive infinity, hard bracket, soft for the infinity. Because of the solid circle, it gets the hard bracket at the -2. And then as far as the inequality goes, all of my x values are greater than or equal to -2. And then to do the range portion, I'm only concerned with the -4 here. -4 is the least y value of all the plotted points. So my range is going to be -4, hard bracket, direction of positive infinity. And then my interval notation, my inequality notation, will use the variable y. All of the y values are greater than or equal to -4.